The numbers suggest we should not be alone. In a galaxy of 400 billion stars, with planets as common as dust, the statistical probability of life is overwhelming. And yet, we hear nothing. We see nothing. This is the Fermi Paradox, the deafening silence of a universe that should be teeming with voices. For 60 years, we have listened. We turned our great ears, the radio telescopes, toward the void, waiting for a ping, a beep, a sequence of prime numbers, a purposeful message sent by someone who wanted to be found. This was the era of SETI, passive listening. But the era of listening is ending. The era of observation has begun. We are done waiting for a phone call. We are now looking for the smoke of their fires. We must distinguish what we are hunting. For decades, astrobiologists have hunted for biosignatures, the chemical exhaust of simple life. Oxygen produced by algae, methane belched by microbes, the breathing of a living world. But as physicists, we are now hunting something rarer, something louder. We are hunting technosignatures. We are not looking for biology. We are looking for industry. We are looking for the indelible scar that intelligence leaves on its environment. We are looking for the thermodynamics of civilization. How do we spot a factory across light years? We use light itself. When a planet passes in front of its star, the starlight filters through the planet's atmosphere before reaching our telescopes. This light carries a fingerprint. The chemicals in that air absorb specific wavelengths, leaving dark gaps in the spectrum, a chemical barcode. Nature produces oxygen. Nature produces methane. But nature does not produce chlorofluorocarbons in abundance. It does not mass produce nitrogen dioxide. These are the spectral fingerprints of industrial pollution. If we spot CFCs in the atmosphere of a distant world, we are not seeing a forest. We are seeing a refrigerator. We are seeing a society that has manipulated chemistry for its own comfort. We also look for the vanity of intelligence, illumination. On a tidally locked world, where one side is frozen in eternal night, nature dictates darkness. If our spectrographs detect a faint, anomalous glow on the night side, specifically concentrated in wavelengths like LEDs or sodium vapor, we are seeing the resistance against the night. We are seeing cities. But perhaps the most undeniable signature is written in the laws of thermodynamics. The second law is absolute. Energy cannot be created or destroyed, only transformed. And this transformation always creates waste. An advanced civilization is, by definition, energy hungry. If they build a megastructure to harvest their star, a Dyson sphere or swarm, they will use that energy to power their computers, their transport, their lives. That energy must eventually be radiated away as heat. If we see a star that is dim in visible light, but blazing bright in the infrared, that is the heat signature of a machine on a galactic scale. And yet, despite these markers, the sky remains dark. Why? We must strip away the science fiction and look at the instrumentation. The reality is sobering. We're trying to spot a firefly next to a spotlight. Our current technology, even the James Webb Space Telescope, possesses a sensitivity gap. We can currently only sniff the atmospheres of planets orbiting very nearby, small, dim stars, red dwarfs. We cannot yet photograph a duplicate of Earth orbiting a duplicate of the Sun across the galaxy. We are not looking through a window. We are peering through a keyhole. Then, there is the question of time. This is the great filter. How long does a technological civilization last? We have been industrial for 2 centuries. In the cosmic calendar, that is less than a heartbeat. If civilizations inevitably destroy themselves through nuclear fire or ecological collapse, they are fleeting flashes in the dark. To find them, we must be looking at the exact right star at the exact right moment in its billion-year history. We may be arriving too early or billions of years too late, staring at the ruins of empires that have long since turned to dust. Finally, we must confront our own bias. We look for solar panels and city lights because that is what we build. But a civilization a million years our senior may have transcended the need for such crude energy. We are searching for the footprints of a toddler, unaware that the adults may be walking on wings we cannot see. Why do we continue this search in the face of such silence? Because a non-detection is also data. If we look and find nothing, it tells us that technological intelligence is rare, fragile, and precious. The hunt for technosignatures is more than a search for them. It is a mirror for us. It forces us to ask, What signature are we leaving on the universe? Are we a fleeting spark? Or will we endure long enough to become the signal that someone else, somewhere else, is waiting to find? The silence is not empty. It is waiting. Produced by Channel Name. References: the NASA Technosignatures report, the Fermi Paradox.